going to speak about the French standard. So you may remember that yesterday we speak about the Dean standard. So don't make any comparison. We try to make it so different that you cannot compare together. So there is no better. Last week, a wise man was visiting the States, and he said that if you want to go fast, you go alone. If you want to go far away, you bring a couple of people with you. And I found this sentence that's the Pope for the few French that was not following. And I think it really like summarized the spirit of EAS here. And it also I want to share the spirit we had with the committee, because you will see that it's not only an acoustic standard, and we try to open up to, we had a lot of end user within the commission, so it will be a bit different than only acoustic. So once I've said that, I have a question for you. I will start with a question. So please do not hesitate to shout words and whatever comes to your mind. I will show you 4 pictures, and I want you to tell me what are the common points between those 4 pictures. People. Yeah. Chaos. Workplace, yes. I was expecting open space because it was the title, but thank you. Yes, it is open space. But the real common point is actually not on the picture, and I was expecting a few French people to actually say that we have the answer and we know. The real answer is that that's the boring part. It will be very short. The common point is that all those spaces in France are under the same standard. So which means it doesn't matter the activity that you're performing. It will be the same acoustic goal that you need to achieve. So which means it doesn't integrate the activity. Sometimes we forgot that when we enter into a bank, there is a few people that are actually working there, even if we are in a hurry, and we need to, let's say, be more precise in the way we define the activity. I will give you very shortly the structure of why we had to do this standard. So of course we have the domain, what we call the risk level, so which is regulated in France. It's not really adapted to the office. And the line that you need to remember for the French situation, it's 2006. It's when an office standard has been launched into the market. Before that, when it comes to the comfort, acoustic comfort, we only had one standard, thanks to the ergonomic field, that they were the first one to address the problematic of acoustic, because they had a very holistic view of basically what was going wrong in the office. The only problem that they had, that's the way they tried to express and the description of the issues, they were not specialists into acoustics, so it was not really realistic, but at least it existed. So then since 2006, we had the environmental performance rating system that was really inspired on the 2006 standard. And then the standard I'm going to present today, the work started since 2007, so a long time ago. I think I need to update my slides. I saw some even more cooler way to present the fact that acoustic is the first factor of disturbance. But I think for all of us here, it's quite clear, and from the sessions, we all agree on that. I'm just gonna go to the perception of the noise and what is the most important and what we need to focus on when we try to work with the office acoustic. This is a study that has been done by ANRS with a quite large panel. Of course, scientific will say it's never enough, but it's more than 700 people, where we clearly see that the most important factor is the intelligibility and being able to hear a message that is not really useful to the activity that we are performing. So that's what we try to work on. So let's define the 2006 standard. This will allow you to understand why we had to do a continuation of it and why we try to integrate the activity. So this standard establishes a link between acoustic quality measurements and the acoustic performance level to be achieved by the implementation of building system. It's quite a usual standard, I would like to say. It defined 7+1 type of spaces, because already in 2006 they were quite smart, because they saw that the real estate and the building industry, we build buildings without sometimes knowing who will be into it. So we need to make sure that the inside, the volume inside is ready to at least have a certain level of performance. It's one of the best seller of the AFNOR. Why is that so? It's because it's very simple. It has 3 levels of explanation for different target group. Let's say a soft part that explained the acoustic challenges, and then he had the translation, technical translation for you, basically. And it made in a way that we had 3 levels of performance: the normal level, efficient level, and very efficient level. So let's say it was a good way to create dialogue around the acoustic and set a clear target that is reachable. What is behind that is that the end user have people that complain about the noise, but there is too much noise. Doesn't mean that much for when we try to discuss all together with the union and end user. I would like to do a very short focus on the parameters that were used that were proposed since 2006. So of course, for the indoor acoustic, we see the reverberation time. With more performance you go, the lower should be the reverberation time. And we had the special decay that was already integrated. It was a DL2. It was not really used because you have a lot of if. Like often into standard, you don't need to use it. So it's a very complex scenario, no? How do you solve this acoustic with all those activity? So what we did, we had to find a structure to being able to see and manage the acoustic challenges. So we used 3 levels of analysis. We have the workstation level, the team, and the department. So we see the acoustic at 3 different levels, and we have 3 leverage. We work with reducing the noise, the discretion, and sound propagation. I will give an example. If you are into a call center, do you need to hear your colleague in front of you if he's spending 8 hours over the phone not talking to you? So we need to reduce the intelligibility, try to do something. So this will be managed by attenuation at the workstation. In the other hand, if you are into marketing or architecture firm, you need collaboration. And the question is, if you make intelligibility possible at the workstation, you need to degrade then afterwards for other teams that are not working together. And of course, we had to take into account the standard from 2012. So we started to work. We knew it because we have been participating also into this standard, so we wanted to use the toolbox of this standard in order to be up to date and using the right tools that were available. So I think we are familiar with this standard now. So this is basically a measurement methodology that allows you to take out single quantity, and those parameters are made to correlate to the subjectivity. We had a lot of debate. We also looked at what Germany was doing, but we went for the D2S. So we choose the special decay rate A-weighted as a parameter to define the sound propagation. I will ask you to focus on this little illustration, and this is the part where working together is very important. What I'm trying to illustrate here is that which acoustic parameter will describe this? Which acoustic parameter will define this? It means that there is other dimension that we can try to include into a standard that will actually try to solve complementary solution. If there is no meeting room, what will happen? People will meet into the open space. Then they will have a behavior that will not be in favor of the productivity of others, because they will, with their speech, disturb others. So this explained a bit the philosophy of the document and all the toolbox. So we went, I'd say, 2007, when my colleague Pierre Chigot was involved, like from a very acoustic, what is existing everywhere in the world, documentation, all the descriptors existing all over the world. We went from that to maybe we need to integrate other parts that will help people. And we went from very acoustic standard to more a process standard, how you can solve the acoustic. So how does it work? I will focus on part 4 and 5 and 6 that might be the most interesting for you. We had to create a process. I think a few people mentioned the real estate and what's going on, but how can you solve the acoustic of an open space if the building is not right? So we created what we call that synoptic for the process, where they need to make sure they respect the standard of 2006 if they want to start to work and create a good... we need to make sure the volume is right, there is a good facade insulation and so on, and then after, once we are in the building, we're going to work on the optimization of the acoustic and integrate the activity. Yesterday, Etienne Pariset talked about a questionnaire. I will go back on this questionnaire. And the idea of this process, it's a different stage. You need to being able to propose the tools. So we are quite free. If you want to integrate the questionnaire, you can integrate it. If you don't need it, you don't integrate it. So we had to do a general process to help people to solve the acoustic challenge. What is something that we did not discuss about this questionnaire? It was not the desire at the beginning. Why did we do this questionnaire? Because the INRS was working on it, and then we used it to do correlation between on-site measurements and subjective feeling, and we made analytics to see which one was correlated the best. We went to see big end users, and we proposed them the document, and the management, they say, this is great. Why is that so? It's acoustic. Slow down. I mean, don't be that happy. But he said, no, it's great. I can use it tomorrow. Which means, as soon as there is a problem, the questionnaire, it's taking action tomorrow. Because between the time you have engineering firm that will come into the process of solving the acoustic, if you're an employee, you will see a guy with a microphone. Like, is your problem taking into account? You don't know. For communication, it's very individual, and they can act faster than engineering coming into the project, or even the construction work. Between the time that there is a problem and the time that they might solve or invest, it's a long journey, and we need to react very fast from the end user point of view. And the second aspect of the questionnaire that was not discussed yesterday, there is a part related to the evaluation of your own health. So sometimes it's quite tricky to implement it to some companies, but the general idea is, and it was the conclusion of Etienne Pariset, is always acoustic the real reason of people complaining? And sometimes we have to do the right things, which means if there is a problem that is not an acoustic problem and people have a health problem, it needs to be identified. And there is doctors and other specialists that can, psychologists and so on, that can help those people. So that's why we had a lot of discussion if we should keep the health part into it. And then the part you prefer. So the acoustic part, we defined it for specific parameters and objective. So we have two types of target, because we were quite bold. We wanted to have a level in activity, but we know that it's impossible to commit it. When you do simulation, you cannot commit I mean, if there is one of you that want to commit in a LAOQ in activity into an open space, please raise your hand. So that's impossible. So what we did, we just say it's recommended value. We use epidemiologic data we had to say, into a call center, this is that type of level. And because usually the first person that will hack is somebody internal. There is always somebody with that can do measurements internally. So at least he knows that if it's bad, very bad, or very, very, very bad. So we leave that, but it's just to give maybe help them to take the decision to act, how to say. And then we have the parameter that you will use and simulate, predict, and commit to, and choose the adequate material. For an end user, when he sees a room, he doesn't see porosity, he doesn't see dimension, he doesn't see what we see as an acoustician or specialist. He doesn't read the acoustic property in a room just by blowing through product. It doesn't have those type of notion. So we need to help him to understand better the space. So we made it into the standard specific part where we explain the priorities. And yesterday, when the Sunbeam study has been presented, we had discussion. Somebody asked, "Did you make the test without the screen?" And that's very interesting part. And we knew that some end user had the question, what is the height of the screen I should use? What is the relation between the sound propagation or the attenuation, depending of the type of ceiling I'm using? What is the priority? Should I work first on the ceiling, on the wall, or the screen? So we have been lucky enough that we work with CSTB and INRS. We made many laboratory measurements, and we also made a lot of modelization based on that. So we are happy to being able to present some help for end user to prioritize their investment, to being able to make the right choice, the choice that will make the acoustic difference. I have been visiting so many end users, and they did not treat the ceiling, and they were buying very, very expensive screen. It's good, but the test in laboratory in semi-anechoic chamber of the attenuation of the screen will not be the same performance in situ. So we needed to give them insight for them to be more correlated to the reality. Some conclusion. So we will have the synoptic approach to give an overview of how you can use this process. We have incorporated a portion to help the assessment of the office acoustic for the end user to understand better how it works and how to prioritize and do the right things. And as I said, a unique acoustic indicator that can relate all the activity and solve all the problem with a high correlation to subjectivity, easy to measure with a very low uncertainty and so on is, for me, at the moment, impossible. That's why we need to extend, and that's the choice we have made with the tree-level analysis. A very important thing is that we had not pressure, but we had the people that, yeah, there's acoustic problem, we should tell people not to speak. No, you should provide them the space to work, and you should, that's the global idea. So we made a clear statement that we need to provide people the space for them to work. And the acoustic, we need to empower them with the acoustic. So that's the reasoning we had. But we created into the annex some tools that, how to say, a behavior, how to use friendly open space. Because, no, go into the room, don't spend 10 minutes over the phone standing up in the open space. It may sound basic for acousticians, but for some people, they don't even realize that, because they don't know that speech will disturb cognitive performance. So we created, we use Orange internal rules that they have, and it's a very efficient way to help to empower the people to act better toward the other and disturb them less. And I'd like to say the questionnaire is a good way to start the dialogue. And as I said in the introduction, if you want to go far away, you need to bring a couple of people. So this standard is not published yet. You can go online and you can put your comments. Not too many, because you are 200 people, and we will have the commission, and we will have to answer to your comment. But feel free to comment. It will publish soon. Thank you.
Thanks a lot, Yoan.